Okay, and we will get started on Chapter 6 with 6.1, Properties of Exponents. A lot of this stuff will probably seem familiar to you because you covered it in Algebra 1, but we're going to go a little more in depth and we're going to kind of review it and add some stuff to what you already know. So, properties of exponents. The first one is the product of powers property. And that says if two things with the same base are multiplied, like a to the m times a to the n power, you add the exponents. So for example, if we had x squared times x to the third, it would equal x to the fifth, because you add up the exponents. Power of a power property is when we have parentheses and we have two exponents. So that could look something like this. We could have 3 squared to the third power. And I like to think of it as we're distributing the exponents, kind of. Not exactly, but that's kind of what it's like. You would do 3 times 2, and you would get 3 to the 6th power. And 3 to the 6th power is 729. So notice in the top one, we added. In the second one, we multiplied the exponents. The third one is power of a product. So if we have two things multiplied together in parentheses, and they're taken to a power. So this would be like, what if we have 2x to the 5th power? Something like this. This would actually be 2 to the 5th power times x to the 5th power. And then we can actually figure out what 2 to the 5th power is. 2 to the 5th is 32. So this would be 32 times x to the 5th. The negative exponent property. When you have a negative exponent, it goes to the opposite part of the fraction. So like if we have a to the negative first power, it becomes 1 over a to the m power. So our example, let's do 7 to the negative second power. What we really do is we kind of flip this or invert this fraction to be 1 over 7 to the positive second power. So notice that exponent becomes positive, which is really 1 over 49. And likewise, if we have something like 1 over 4 to the negative third power, negative exponents can become positive when you flip the fraction. So it becomes 4 to the third over 1. And when I say flip the fraction, I'm sorry, you don't actually flip it. You just take whatever has a negative exponent, you take that base and put it to the other side. So 4 to the negative third would go to the top. And 4 to the negative third power on the bottom becomes 4 to the third. And 4 to the third power is 64. So this would be 64 over 1, which is 64. The zero exponent property says anything to the 0 power will always equal 1. So if we have 6 to the 0 power, that will equal 1. If we have x to the 0 power, that will also equal 1. Anything that goes to the 0 power is going to be 1. The quotient of powers property. If we have two things with the same base being divided, we subtract the exponents. So for example, if we have 4 to the 5th on top and 4 to the 3rd on the bottom. Okay, so they both have a base of 4. We're going to subtract the exponents. So this will equal 4 to the 5th power minus 3, which would be 4 to the 2nd power, which is 16. Okay, likewise, if we have, let's say, 7 squared on top and 7 to the 5th on the bottom. So you see the bigger exponent is on the bottom. This would end up being 1 over 7 to the 5 minus 2, because 5 is bigger than 2, so that's where we're going to put the exponents, which would be 1 over 7 to the 3rd power. Another way I think of this is, what's bigger, 5 or 2? How much bigger is it? It's 3 bigger. And 1 over 7 to the 3rd is going to be 1 over 343. Okay, and then power of a quotient is when we have a fraction inside parentheses taken to an exponent. So it would be like 1/4 in parentheses to the 4th power. Everything in parentheses goes to that power. So this would be 1 to the 4th power over 4 to the 4th power. 1 to the 4th is 1, and 4 to the 4th is 256. So those are all properties you saw before. We're reviewing them, doing a little more with them in Algebra 2 than you did with Algebra 1. Okay, so a couple examples. Example 1 says evaluate the expression. If we have 6 to the 3rd times 6 squared, we would be adding up the exponents, so it would be 6 to the 5th power. And then you would use a calculator. 6 to the 5th is 7,776. Number 2, 4/7 to the -2nd power. So what I would do is I would take everything in parentheses and it goes to the -2nd power. Now, anything that has a negative exponent has to be put to the other side of the fraction. So 4 is to the -2nd power. That will go to the bottom and become a +2. 7 to the -2nd power would go to the top and become a +2. So it would be 7 squared over 4 squared. And we would get 49 over 16. And that would be our answer. Number 3, I like to break these into like different parts. So I like to look at it as, what are the coefficients? So right here we have 12 over 33. Can we reduce those at all? So 12 over 33, these both can be divided by 3. So this would become 4 over -11. Okay. Then we have ends. We have end of the 4th and end of the 6th. Where are there more ends? There are more ends on the bottom. And how much bigger is 6 than 4? Well, I'll show the work here. Be n to the 6 minus 4 power. Then look at the q's. There are more q's on top, so it'll be q to the 7 minus 3. So when we solve this or simplify this, it'd be 4 over -11. It will be q to the 4th power, and it will be n to the 2nd power. So again, I like to look at it all separately. The coefficients, the n's, and the q's are all separate things. Number 4, when we have negative exponents with fractions, the first thing I do is make all the negative exponents into positive exponents. So like w to the positive fourth power would stay on the top. M to the negative sixth would get moved to the bottom and become positive sixth power. N to the third would stay on top. W to the negative fourth, that's going to move to the top because it has to become positive. The negative exponent will become positive when you move it to the top. M to the positive second would stay on the bottom, and N to the eighth would stay on the bottom. Okay, so anything that's negative got moved and became positive. So I highlighted the ones that moved. Everything else stayed where it was at. Once we move them, now we can simplify. So do you see that on top, the W's, W to the fourth, W to the fourth, you put those together and they will become W to the eighth. 4 W's, 4 more W's, put them together, 8 W's. On the bottom, we have M to the sixth times M to the second. Put those together, you would get M to the eighth. And then if you look at the ends, there's an N to the third on top, and there's an N to the eighth on the bottom. There are more N's on the bottom, and how many more? There are 5 more. 8 is 5 bigger than 3, so this would be your simplified answer. And again, I like to go get rid of negatives, move them so they become positive, then combine what you can combine. So we end up with W to the eighth over M to the eighth times N to the fifth. And our last one. Okay, a lot of different ways you can do this. Me personally, I'd like to make this into one big fraction and then reduce. So I would put 30 first. Then we have D to the seventh times V to the fourth. And on the bottom we have 5. D to the third times D squared is D to the fifth. And then we have V to the fifth. Okay, so the top I put together and the bottom I put together. Now, 30 over 5. 30 over 5 can be reduced. That can be divided by 5, and you will get 6 over 1. D to the fifth on the bottom and D to the seventh on top. Where are there more D's? To the seventh or to the fifth? To the seventh is bigger. And how much bigger? 7 is 2 bigger. So it'd be D to the second power on the top. And then we have V's on the top and the bottom. V to the fourth on top, V to the fifth on the bottom. V to the fifth is bigger, and how much bigger? 1 bigger. So we would just have V to the first. So 6D squared over 1V. You could also put down 6D squared over V. That's the simplest way to write it. All right, and that's how we reduce our fractions with exponents. Okay, and I'm going to quickly run through scientific notation. This is a number in the form C times 10 to the n power. Fix this. Where C is less than 10 and it's greater than or equal to 1. And n is an integer. So if we have 0.00045 times 123 million, okay, if we wrote 0.00045 in scientific notation. We work from left to right and find our first number. The first number other than 0 is 4. The decimal will go in between 4 and the next number. So this would be 4.5. What that does is it gets it in between 1 and 10. Then we're going to put times 10, and 10 is going to go to an exponent. It's going to be either negative or positive. And so if we are moving to the left, which we would go to the left 1, 2, 3, 4, that means it's going to be to the negative 4th power. Same thing with our next number. Starting from the left, find your first non-zero number, and that will be 1. The decimal goes between there, so it'll be 1.23. This time, we are moving to the right, 1, 2, 3, 4, 5, 6, 7, 8. So it will be a positive 8 as the exponent. So scientific notation would be 4.5 times 10 to the negative 4th times 1.23 times 10 to the 8th. And what we would do is you could rewrite the order of this as 4.5 times 1.23 times 10 to the negative 4th times 10 to the 8th. 4.5 times 1.23 is 5.535. And 10 to the negative 4th times 10 to the 8th would be 10 to the positive 4th. So this would be how you wrote this in scientific notation. And we will quickly run through the word problem. It says in 1997, Denmark had a population of 5,284,000, and the GDP was 131,400,000,000. Estimate the per capita GDP. So the GDP per capita would be GDP on the top, and it would be the population on the bottom. So the GDP is right here, the 5 million. So if we start on the left, the decimal will go between the 5. Oh, excuse me. That's the population. For the population, the decimal will go between the 5 and the 2. So it'll be 5.284 times 10 to the, and let's figure this out, 1, 2, 3, 4, 5, 6 to the right. So it'll be 10 to the 6th. For the GDP, the decimal goes between the 1 and the 3. So it'll be 1.314 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 to the positive 11th. Okay, so this is how you'd write it out, the top and the bottom. And then we can figure out what is 1.314 divided by 5.28. That would be 0.2489 roughly. I had to round that. And then if you look at 10 to the 11th over 10 to the 6th, that would be 10 to the 5th power. Okay, now this gets trickier because our first number is not between 1 and 10. So now we have to move our decimal to here. This would be 2.489 times 10 to the negative 1st, because we'd move it to the left to go back to where we were, times 10 to the 5th. So now we'd end up with 2.489 times 10 to the 4th power. So that got tricky because we had multiple things when moving decimals with scientific notation. But scientific notation is just properties of exponents. Okay, and we're going to stop right there.